In this video, we will see the different steps of establishment of service request in 5G networks. The 5G service request procedure is triggered when a UE needs to send uplink data, receive data, send signaling data, or respond to a request for paging from the 5G core. For those who are new to the topic, paging is a procedure to notify idle users not involved in a data session, checking if they are available on the network or in a disconnected mode. To connect to the Internet, a 5G user equipment, UE, needs to register with the 5G network, as explained in the previous video. After registration, the 5G UE needs to create an Internet data bearer tunnel with the destination data network through the 5G UPF. This is called a PDU session, Packet Data Unit Session. Each PDU session is uniquely associated with one data network and network slice. For example, we can have a dedicated PDU session for Internet traffic with specific quality of service and throughput, depending on the user's subscription. The same applies to voice traffic, enterprise campus traffic, low latency service traffic, IoT traffic, and so on. Now let's go deep dive into the 5G service request call flow for more details.
The 5G UE service request procedure involves parameters such as 5GSTMSI, PLMN ID, and establishment cause, among others. It is important to mention that the 5GRAN selects serving AMF based on the 5GSTMSI included in the service request. After authentication and security command, the AMF needs to allocate a suitable session management function SMF through the NRF. We explained previously that NRF play a role similar to DNS, but instead of using domain name as an input, we use feature capabilities such as target network function NF type, requester NF type, and service type, among other parameters. 5G core network functions are running on a cloud-native environment, so we assume that we have hundreds of 5G network functions that can be created and terminated based on several events and conditions, so it will be very hard to publish each new NFs manually to the other NFs, which it will end up with 10,000s of configuration and operational complexity. So NRF plays a crucial role in 5G. We need to understand why AMF must contact the SMF. The SMF is the main controller of the PDU sessions. Any modification, update, deletion of PDU session must go through SMF. Let's give some examples. In case of a context modification, where there is a need to modify or update the existing context of a PDU session due to changes in QoS, quality of service requirements, policy updates, or other factors that necessitate an adjustment in the session management parameters. For example, a user is streaming using standard video quality and would like to change to full HD quality, then seamless quality of service update must occur to the PDU session. Another case service requirement change, for example, a UE is browsing Internet through Internet PDU and would like to have voice over 5G call. A new dedicated QoS flow needs to be created in the PDU for the voice call voice service. The SMF sends a request for updates to the PCF to receive updated policy information for the PDU session based on the access type, user location, service type, etc. This interaction is important. The PCF needs to be informed of the user equipment dynamic changes, and also the SMF needs to get user-specific policies to be applied when needed. It is important to mention that interacting with PCF now is not an arbitrary decision. Initiating the policy control function, PCF, after allocating resources and discovering that the PCF mandates the non-establishment of the PDU session can result in resource wastage. After PCF interaction, the SMF needs to select a UPF for the requested or updated PDU sessions. UPF selection in a 5G UE service request can occur through UPF configuration via the OSS, a manual and challenging process, or through NRF. Now let's talk a little bit about user plane function UPF. The UPF is divided 4 types of UPFs. UPF Type 1 Anchor UPF is a UPF directly connected to the data network. Internet, for example. Type 2 Intermediate UPF, which is a UPF used to interconnect multiple UPFs. Type 3 Uplink Classifier UPF, used to route traffic between local data networks and global data network. And finally, branching point UPF is used to forward the uplink traffic towards different anchor UPF and merges the downlink traffic from different anchor UPF to the user equipment UE for IPv6 multi-homed PDU sessions, where the UE can support multiple IPv6 address and simultaneous PDU sessions. If an anchor UPF is directly connected to the access, then core network side tunnel is activated with anchor UPF. Otherwise, it is activated with intermediate UPF. Once done, the SMF reply to the AMF with PDU session information and quality of service information. Technically and in a simpler way, the radio access network should respond with the access network tunnel information and the accepted QoS. The access network will forward access tunnel information to UPF through SMF to establish an end-to-end traffic tunnel from the UE to the anchor UPF. It is also important to mention that the service request procedure can be triggered by the network if the UE has buffered downlink data to receive and it is in an idle mode. Then the UE will be notified from the core network and service request procedure, similarly to what was explained, will be triggered.
We have reached the end of our video. The service request procedure requires communication and service parameters negotiation between different network functions to enable end-user services seamlessly and with the best experience. The presented signaling flow is attached with the video, and I encourage you to check 3 GPP specifications for more detailed scenarios. Thank you for watching.